Welcome to another tutorial. This is part 3 of my external cheat in CS2. This one I'll show you how to make a simple ESP in GDI, C++. We're first going to start off by finding the entity list, finding the coordinates of ourselves and the players around us. We're going to create an overlay, and then we're basically going to use the world to screen function to display those locations using boxes or really whatever you really want. First thing we're going to have to do, we're going to have to scan for our own health as always. And then we can actually find the entity list very easily. Let's see. Here we go, we found it pretty fast. And basically, this is a value, part of the player class. Now, in source games, we have the local player class, and you also have the entity class, in which entity class inherits the values or the objects inside from the local player class. So like coordinates, health, and stuff like that. So that's why we're starting to scan for ourselves, because it's much more easier, because technically we're the base. So now let's actually find over here. We're gonna go see what accesses this address. We're gonna go to the register. So here, this is our offset, and our offset gets added to a register, register, and this register holds our value to our local player class and the entity class. Our local player is part of the entity class as well. So we're gonna search for basically an address that holds this hex value, which is gonna give us a list of pointers. What we're trying to search is a static pointer. In cheat engine, these are annotated as green. So here we're gonna have 2 as expected. In previous videos, we found out that this one over here, it's actually over here, this one is the local player class, and this one is our entity list. So now what we're gonna have to do really is just right click on this, browse this memory region. We're gonna go to tools and dissect data structures. Here we're gonna press on structures, define a new structure. Doesn't really matter. Put the size. I usually on default is like 4,000 something. I put it to 5,000. I don't know. And here we have it. Actually, it's a little bit different than CS:GO. It's CS2. It's basically base is much more different than CS:GO. So now we can see that we have our C player pawns are basically the players, and each player gets like a observer pawn. Now we can take a look at this, and you can see that each one of them is separated by 10 bytes. So it's not different than CS:GO. Cheat engine has a problem. Here it should be a CS player pawn, but if I refresh this multiple times, I'm gonna get the expected result when CS player pawn is also gonna be here. At 0, we have our local player, because we can also do this and, for example, start scanning for this guy's health. But the problem is that 0 was gonna be this guy, and then we're not gonna get all the players, because each player has their own ID and it comes one after the other. So that's why we start with our local player, because he's basically the base. He's the 0. Okay, so now the next thing that we have to find are the X and the XYZ coordinates, and for our player, for our basically entities. So now to do this, our well-beloved game has this function called CL show pause. CL show pause. We have to set it to 1, and you need to have server cheats on. And it's going to show our basically our view angles and our position. First, let's start scanning for our X. It's going to be a float, and we're going to be searching for 299.44. Let's scan. We're going to see it now. Yeah, it's from our center of the map. So now let's search for minus 0.88. already have only 7,000 results. Now let's check a little bit for unchanged values, because there's a lot of values that just change for no reason. And okay, after scanning for a pretty long time, you're gonna see that you're gonna get to a point in which you can't really go down in values. You can't really find a more accurate set of values. In this case, I managed to go down to 2,630 results. But now what we have to do so we can really like find this, let's take a look at the address of our local player class. So let's make this a pointer and actually see the address this points to. So 14D64. Okay, so let's go to 14D64. Okay, so after we went to 14D64 over here, let's actually take a look at our address once again. 14D64 74. Yeah, we have it here. 745400. So we have these 4 addresses that match our stuff. So this is very, very close to our local player class. So that's why we are allowed to assume that they are correct. If they're not correct, which is the worst case, we have to go through this again and do some more debugging, and it'll take a long time. Let's see what axis is it. We don't really have an offset over here. I don't think that 70 is an offset. We can actually check. Who knows? Maybe it is. I'm just assuming wrong. So let's see. See, doesn't really point to anything. So it's not this one. Hey, CC4. That might be an offset. I'm pretty sure that is an offset. So let's go RBX. Looks pretty familiar, if you ask me. So now let's see. Okay, we found something. What am I doing? And here we go, we found it. So it's not this one because we already checked. Well, let's check for these ones as well. 02 DC. Let's see RBX. It's the same thing, really. We're gonna keep both of them because we're not sure, and it's pretty wrong to risk that much. Now let's go back to float, and you guys should do the same thing for the Y and the Z. So see you after you scan this. Now, after scanning for a while, you should finally find that 2 X's, 2 Y's, and I found 1 Z. Well, the peculiar thing about these 2 X's and 2 Y's is that when you go into both of them, you see that this has the offset of D2C, and this one over here has also the offset of D2C. Well, this means that they're grouped, really, or it's an error from cheat engine. Now, I only found 1 Z for some reason, and when I looked for this, it's D34. Now, now going into now researching a little bit player class, I saw that basically these are 4 bytes apart from each other. So if I take, for example, this one over here, so for example, if I go to my local entity health over here, remember to change the type from 4 bytes to float. And for example, I already tried this. So for example, D2C is going to be our X. D30, it's gonna be our Y. And D34 is gonna be 54.66. Now this is perfect for us because we finally found the offsets. Now the very last thing that we need to find so we can actually start creating our ESP for real, we need to find our view matrix, also known as the view projection matrix. Is a 4x4 array in which it tells the game it basically tells the game how to render the world around us. Now to find this, we're going to use the command cl show pos1, and we're going to look at our view angles. Our view matrix is not related to our view angles, but when our yaw is negative, so are our view angles. Our view angles are ranged between -1 and 1. So I think you get the point. So let's actually start scanning for this. So first we're going to have to go here and we're going to put it to float. The matrix is a float. And we're going to scan for values between -1 and 1. Now this is going to take a very long time because the next thing that we have to do is we just have to move our mouse and we basically have to scan for a changed value. Now let's scan once more for a changed value. So now what do we do this for? We just do it so we can get rid of all of these ton of values because there's too many and we can't do anything. Scan it again. Okay, finally scanned faster. Now we only have 3 million, which is still a ton. So now let's do this a few more times. There's one trick about the view matrix, and same with the view angles really, is, for example, results. So if you don't move your mouse, your view angles and your view matrix is going to stay the same. So now let's check for an unchanged value. See, and we can also move around actually. We can also jump, but be aware that if you jump too high from a high place, you're actually gonna get your view angles to move, so your view matrix moves as well. Because if you jump from too high, you're gonna get damage, and when you get damage, you're gonna have this like kick effect. If you, after each scan, after trying everything, you're still gonna have like 1,000 results, let's say. One way is pretty risky, is to basically jump, and while you're not moving your mouse, you need to time it correctly. But when you hit the floor, and you need to wait a little bit, and you need to scan for unchanged result. I'm not gonna do that yet, because now what I want to do, I want to press for a change value and actually filter these values a little bit by going over here and scanning for a value between -1 and let's take a look at our yaw. It's -49. So that means it's going to be a value between -1 and 0. So that took down things very fast. So now let's get our yaw positive. So now just to speed things up, let me actually go here to this ledge over here. Let's actually scan for a changed result. Now let's jump, basically. No, let's just drop and then we're going to scan for unchanged. Okay. I already scanned for unchanged and it went down nearly half. Like half. Okay, 69. Now this is a little bit scary because you don't know that if you got rid of actual good values and possibly your actual view matrix. Now we only have 69 results, so let's do this one more time. I guess that was enough. Let's wait for our values to load. This cheat engine is really, really slow. And you can see these red ones basically tells you that they changed. They changed, that one turned to 0. So let's actually delete these red ones. Okay, and we only have 13, so let's just take all of them. So we can get rid of this crazy lag. Okay, here we go. We're not lagging anymore. We're chilling. So now, to filter things out, because we have a lot of values, and let me just tell you, the view matrix is not part of your local player class. Your view matrix is part of, it's basically its own relative, it has its own relative offset. It's its own thing. Now, there's a lot of values that hold a lot of addresses that hold the same value. So now let's actually delete all of these addresses that hold the same value and just keep the different ones basically. Now we don't know which one is which. We have to change this to a hexadecimal, both of them to a hexadecimal, and we're gonna basically search for addresses that hold that basically hold this address over here, and this address over here is a float. Okay, change it to 4 bytes, and now change to hex, and we're searching for our view matrix value, but in hexadecimal. And you can see that we found a lot of results. And we have here 3 static pointers that hold the float value of our supposed view matrix. All we basically did, we searched for pointers that hold the hexadecimal value that represents the float of our view matrix. So now we have 3 of each. We don't know which is which, but we're going to make an application, and basically when we're going to have to input our offset for our view matrix, we're just going to try all of the values in. Welcome to the coding part. As you can see, I took my bhop script and put it inside a comment. And I also changed the subsystem from console to Windows, so we can actually create a Windows window. So now let's go through what we wrote. So we first created our Windows entry point. We pass our instance, our previous instance. If we have any more commands or anything extra, we're not going to use this nor this. And we need a command show. Over here of type int. We create our class name, then we create a window class, and then we initialize our window class of the size of the actual window class. And now we stop here. We actually created our window procedure function, so we can actually handle all our messages. We actually pass our Windows procedure function in this for this object over here of our window class. Next, for the class name of our window class, we just set it to the class name that we already initialized here. And the H instance for our window class is gonna be our instance. And the styles, I just put these ones over here. They're pretty common. Now we're gonna register the class. We need to pass through the address of our class. Now we create a window. Here it's gonna ask us if we have any extended styles, if we have any like extra styles. We know we don't. We pass in our class name, window name, and now the styles, which we put them to transparent and topmost. The coordinates x and y on our screen where the window's gonna be, I put them to, I guess, just these things is gonna let Windows decide where they are gonna be. Then I created 2 globals for width and height. Pass them through here. Now it's gonna ask us for a window parent, a menu parent, and for our instance where the window should be created. And now here we just put it to null. Last one is also useless really for extra stuff. Now we do some error checking. So if our window is null, we return 1. And now here we're going to use the set window position. So we're actually going to set the position of our window to a specific set of coordinates. And I use this, and you guys might ask, why not just put the coordinates here where the window is going to be created automatically? Or maybe sometime you would actually want to automatically set your window on top of your game. So this is an example of how you can use this function. Now you show our window, and now we create a variable message of type message, and now we do our main while loop. And it's while we get messages, we store the messages inside this variable over here. It's gonna ask us for a window. In this case, I put it to null because it's not necessary. And now here for the filters, we don't really care about the filters. We put them to 0, 0. And we're gonna use the translate message function, the dispatch message function for our messages. So we translate the messages and we actually send them to our Windows procedure, and we can actually handle our messages. So now let's get into the handling our messages. Okay, so let's actually go through what we wrote over here. So we first handle our VM create message, which is when our window gets created. And we set the window style to a layered window with an alpha channel, so we can actually make the window transparent. And now we set the layered window attributes to alpha, basically, to 100% transparent. We handle our VM erase background, so we actually like correctly handle this. Because when, for example, when we call functions like invalidate rect, we're gonna it's gonna send this message, and to handle this, we just simply have to return true. And now case on VM paint, which is basically where we're gonna draw our stuff. This is the message for drawing on our window. We have to create basically a device over here and a paint structure. And here, this is basically how I personally refresh my window. I set the background mode to transparent. I create a brush, which is white, and then fill the whole window white, then delete the object. Then I draw my stuff here and paint and invalidate rect. Basically refreshes the window. And basically that's it. On VM destroy, basically when the window gets destroyed, I just use postquit message, which closes the program and sends the as end message 0. And for the default, I let Windows decide all of the action that should be taken on all of the other messages that we did not handle using the def window proc, default window procedure. Okay, so if we actually run this, you can see that we have a transparent window over here. And it is called ESP CS2 as we expected. So now let's get into the part where we actually have to code our ESP. I won't be able to explain everything. For example, like the world to screen function, because it is actually pretty complex, and it's a complete topic that should be made in another video. But I will be trying to explain as much as possible. First, we have to create two structures, one for our view matrix and one for our vector 3, so x, y, z really. The view matrix, like as I said, it is a 4x4 array. Now, creating a structure of a 4x4 array is very simple, but we actually need to overload an operator with the operator like this, so we can actually use it inside our world to screen function, which basically transforms. You only need to know about the world to screen. It just transforms the 3D environment into a 2D screen, basically. So you can actually draw your things there. So let's actually create our structures. Okay. So let's actually look at these two functions over here. So first of all, this is this very, very stupid box over here, which does not take into account the distance between the head and the feet. So basically, when you go back, it's really gonna like enlarge the box. It's not gonna be accurate at all, but it's only for testing, of course. And you guys are gonna find out by yourself how to make if you want to like actually fix this. And here is just a draw line function. Just draws line from point for some points to some other points, basically. And now let's actually get into the function where we actually create our ESP. And actually, before we get into ESP, actually be very, very nice if what I'm gonna do, I'm actually gonna create a namespace with all my offsets that I found, and you guys should do honestly the same. It's just easier. Okay, here we go. So you guys won't be needing V's and most of these other stuff. You won't be needing force attack, force jump, but I just put all the things that I found along while making these videos, really. So let's actually create our ESP. Okay, so we're finished. So let's actually go through this code really fast. We slip our threads so we don't use too much memory, and we actually don't lag a lot. We first create our local player, our view matrix, local team, local health. Now we loop through the entity list. We get their health, their team number, and now we do some checks. If our local player is not present, then we continue. If we don't have our entities, we continue. If our local health is smaller than 0, higher than 100, and same thing for the entities, we continue. And if our local team equals with the team of the enemies, we continue. So we ignore all these things. And it just, so if by continue, by all means, the while loop basically stops the structs here. So if this is true, it continues. So that means that the while loop stops here and then repeats all the code once again and does this check again until it's not true and you skip it. Now we create the X position, the Y position, the Z position for our entity. I know it's very shitty because we're using a lot of memory reads, but that's all right. It's just a very simple ESP. Now we actually put all of these values inside a vector-free pos. Now we create our head. I did not use a bone index, so I just set the head to the position of the player, but for the Z coordinates, plus 50, so that's basically the offset, like to the head, I guess, higher to the head. And now we actually use our wall to screen function, so we transform the 3D environment into 2D, so we can actually draw it. We do this check over here, and then we draw our box and our line, basically. So now the last thing that we have to do is just call our function here, run the program. You're going to see that it will work. Build it. And you can see that it's flickering a lot because we don't have any double buffering. Open your game and put your ESP on top of it. You can see the box and you can see the line. It moves around. Of course, there's a few more errors. For example, that over there is the center of the map. But I can make a really quick check so it does not display that. But that's all right. And also all these little things. I can do more. You guys just have to do more checks. And you can see that it works. And when you move around, it basically draws the box. Well, it's pretty shitty because we don't have any double buffering. So actually, let's actually make double buffering really fast. I won't be explaining it too much because the video is already taking too long. And you guys are going to see how it looks with double buffering. And now, because we're actually done, we can, guys, check out the things that you have to do for the double buffering. And let's actually start the application and see how it looks with double buffering. As you can see, there is no flickering. And now if we take the ESP and put it exactly on our window, you can see that it is not flickering at all. It is pointing through the enemies through the wall and everything. Of course, there are some errors, especially with the boxes. Very, very shitty. The boxes are very, very shitty. And as you can see, the actual coordinates, they might not be the actual vector pos, so to their like actual position. But it is what it is, and look at that. It's very shitty because the box, I did not take into account the height of the player and everything. But it does works. So yeah, thank you guys for watching this video, and next time maybe I'll do something else and try something else. Okay, see you guys.